So in this video, I want to go over examples of alkyl halides. First one is this molecule. This molecule has a name called Freon. Okay? And Freon is the molecule that's in refrigerants. Now, that's not the IUPAC name. We want to name that using the IUPAC. So we have to first find the parent. How do we do that? Find the longest carbon chain. Now, it's 1, 2. So I know we have a ethane as our longest parent chain here. Okay. But you got to be careful because sometimes people see this chlorine right here and for some reason thinks it's a carbon. And they go 1, 2, 3, and they think the parent name is propane. Something to be aware of. So if that's our longest chain ethane, what are the substituents? Well, we have two fluorines. So that's a fluoro and a fluoro, and then a chlorine, chloro. Now we have to make sure we're numbering the longest chain, or the parent chain, in the proper way. So I could have numbered it in those two ways. So the goal is to number the carbon chain and bumping in to our first substituent. So if I number in blue, I have 1, 2. I bump into our first substituent at carbon 2. In contrast with the green numbers, we bump into the substituents at carbon 1. So the numbering system has to be 1 to 2, like that. So that means fluorine is on carbon 1, same with that fluorine, and same with that chlorine. It's kind of pretty easy looking, I think. Now we have to put this all in alphabetical order. When you have two groups that are the same, we would rewrite that like this. 1,1-difluoro. And now we have to alphabetize the substituents. And the prefix, we ignore, so we're comparing the F to the C. And C comes before F. So we would name this molecule 1-chloro dash 1,1 dash difluoro. So we've got our substituents. Now we just have to tack on the parent name. 1-chloro, 1,1-difluoroethane. And that's the IUPAC name for Freon. Now if you saw this molecule on the exam, you might start wanting to freak out. But you need to just calm down and go through the process. And what's that process? We have to find the parent. That's the first thing that we want to do. And so I'm just trying to find the longest carbon chain. So 1, 2, 3, 4. Are there any other carbons? And there's not. So butane would be our parent. Next, if that's the parent chain, everything that's branching off of that parent chain is a substituent. So I have a bromo, another bromo, a nitro, and an iodo. And then another bromine, or a bromo. So we have quite a bit of substituents. The next thing that we need to do is number the carbon chain following the rules. And what's the rule? We number the carbon chain and we want to bump into our first substituent with the lowest locant number. So if we go to carbon 1, we bump into our first substituent on carbon 1. So that looks pretty good. But what if we numbered it in the opposite direction? Now, at the pink carbon 1, do you see how I bump into a substituent as well? But what's the difference between the pink carbon 1, and the blue one? The blue carbon one, we only have 1 substituent. And in the pink carbon one, we have 3 substituents. So the first criteria is you want to find the number of the carbon chain that bumps into the first substituent. But if there's a tie with that locate number, you want to give, in this case, you want to give 3 substituents the lowest locate number compared to just 1. So we're going to number this in the pink because we give 3 substituents at carbon 1 a locate number of 1. Wait, that should be 4. So with this numbering scheme, I see that we have 2 of the same, iodo. So we can combine that into a 1-diiodo, like that. What's interesting here is we have 1 bromine on carbon 1, we have 1 on 3, and 1 on 4. We can take those 3 and combine it into just 1. We could say 1, 3, 4. How many bromos are there? Tri-bromo. So we don't need that anymore, or that one, or that one, or those 2. We've combined them. And then we just have our nitro. And where's the nitro at? 2-nitro. And I just had to double check, have I accounted for every single substituent over here? And I believe I have. Now we go and we have to alphabetize our substituents. Prefix we ignore, so B, N, and I. So B comes before, is the first. So we'll put that down. So we have a 1, 3, 4 tri-bromo. What's next? I over N. Believe that's right. 1 diiodo. So we got that one, and 2-nitro. Okay, are we done? No, because I haven't put the parent name. So that's how we do it. So when you first look at a problem, you might get a little nervous and be like, oh, this is complex. But you see how I just go through the process? Parent name, substituents, numbering the carbon chain in the correct way, then alphabetizing. It's that process there. Okay, first step. Parent. Let's see, 1, 2, 3, 4, 5, 6. So that would be hexane. So that's the parent chain. Then we have a nitro group right there. That's coming off of the parent, another nitro, and then a chloro. Now we need to number this in the appropriate manner. In the blue numbers, I bump into my first substituent at which carbon? 1, 2, 3. I bump into this nitro at carbon 3. But could we have numbered this in a different way? To bump into a substituent at a lower number. I bump into the chlorine at carbon 2. So the green numbers are going to win. That's the best way of numbering this. So that means our chloro is at 2. And we have a nitro at 3 and 4. But remember, we can take those and combine those like this, 3,4-dinitro. Now we just have to alphabetize N versus C. So C wins, so that's going to be a 2-chloro. And then a 3,4-dinitro. Dinitro. And then the parent name. Hexane. Perfect. Now let's take a name and draw the structure. So the first thing that we need to do, find the parent. And I like to just draw that out. How many? Pentane, so that's 5. So 2, 3, 4, 5. There's 5 carbons. 1, 2, 3, 4, 5 carbons. And then it says that we have, what are the substituents? We just have one type of substituent, fluoro. How many of them do we have? Tetra, meaning 4. And what positions do we have them at? Carbons 1 and 4. So if I call that carbon 1, then where's carbon 4? Right there. So it's just telling us to put 2 chlorines on carbon 1 and then 2 chlorines on carbon 4. Like that. And now we just double check ourselves, like, hey, does that, if I saw that structure, would I name it this? Well, let's see. So 5 carbons, so that's a pentane. So I'm just doing our parent, and that's pentane. Okay. And I see I see 4 chloros, right? So that would be a tetrachloro. But the way I have this numbered, I have a 2, 2, 5, 5 tetrachloro. That doesn't make sense, right? I thought it was a 1, 1. What did I do wrong? Well, I numbered it wrong. I had to number it in the opposite way. 1, 2, 3, 4, 5. And why is that? Because in the blue 1, I bump into our first substituents, the 2 chloros, at carbon 1. So I drew it right, but then I kind of made a mistake with how I was naming it. But that mistake is very common among students, numbering that carbon chain in the correct direction. So that right there should be our 1, 1, 4, 4, like that. So we did, in fact, take that name and drew it correctly and renamed it. Eventually, we got to the correct answer. Okay, we have a 6-iodo 1,2-difluorohexane. Find the parent name, draw it. 2, 3, 4, 5, 6. What type of substituents do I have? I have a fluorines and iodine. Okay. It says I have 2 fluoros at position 1 and 2. So if I put a fluorine there and call that position 1, and position 2 put another fluorine, so that would have to make 3, 4, 5, 6. That would have to mean that is the 6. So that means my iodo goes there. Now, does that make sense? Could I look at this structure and name it? Well, we first have to find our parent, which we did. Our parent is hexane, right? Because I counted 6 carbons. Our substituents are iodo. And then we'll just skip right ahead to the difluoro. So we have our substituents, but did we number the carbon chain right? Now I look at this and be like, hey, the pink one, I bump into my first substituent, the fluorine, at carbon 1. But then in the green numbers, I bump into the iodo at carbon 1. So there's a tie. So how do we break this tie here? So if you pay attention very closely to the bullet points that illustrate the rules. So I'm going to read the rules on how to number this carbon chain. So the first bullet point says this: choose carbon 1 so that the substituent that is encountered first has the lowest locant number. So we did that. 1 and 1. We both bump into a fluoro or an iodo at carbon 1, depending on the direction that we're numbering it. Okay? So that doesn't help us. So bullet point 2. If each choice for carbon 1 results in a tie for the locator number of the first substituent, then carbon 1 is chosen so that the second substituent encountered has the lowest locant number. So we're looking at the second substituent. So if we go in the green numbers, what number do we bump into our second substituent? Carbon 5. But in the pink numbers, when do we bump into that second substituent? Carbon 2. Boom. We've broken the tie right there. Okay. So the correct numbering would be in pink. So that would be a 1-2 or comma 2 dash and then 6 iodo. And then you can see when we put it all together, we would get the same exact name. Okay? Now let's change this up ever so slightly so I can illustrate the rules here. Okay? What if I put another iodo here? Just change it up a little bit. 1, 2, 3, 4, 5, 6. How would we name this guy? Well, the parent name is still the same. We have 2 iodos now, okay? So we would go diiodo, difluoro. Now the numbering scheme here. So we bump, so the first bullet point, number the carbon chain in such a way that you bump into your carbon 1 with the substituent with the lowest number. 1 and 1. And then the next bullet point said to break the tie by finding the second substituent. So in the pink numbers, we bump into our second substituent, carbon 2. And in the green numbers, we bump into our second substituent at carbon 2. We have another tie. So there's the third bullet point. If there is still a tie after looking at the second substituent, keep looking to break the tie by giving the lowest possible locator number to the next substituent encountered. There are no more substituents. Okay. So we still have a tie. That one didn't help us out. The third bullet point. The fourth bullet point. If a tie cannot be broken in this way, repeat these steps so that the lowest locator number is assigned to the substituent whose name is alphabetical. Whose name is alphabetically first. So all we have to do, I versus F. And we know F comes first in the alphabet. So that means we're going to number in the pink numbers. We had to break the tie somehow, and it was alphabetical. And so we have a 1, 2, and then a 5, 6. We just put it all together. So we would have a 5,6 difluoro. Wait, what am I doing here? Let's calm down here. I'm messing up. Fluorine comes, yeah, so that should be the 1, 2. And then 5, 6. There we go. That's alphabetical order and the proper numbering. 1, 2 difluoro. Dash 5, 6 diiodo. And then hexane. No period. Just like that. So that breaks that tie.